Welcome everybody. Thank you very much for the introduction. Yes, we together with our colleagues from Wesseling had the chance to do our investigations on the microplastic along the whole Danube River and also including the Tisza River, and the main goals and the focus of our work was not so much to find out how much microplastic is in the Danube River and is in the Tisza River, but more to find out which methodologies should be used or could be used in the future for monitoring, for a longer monitoring in all the countries along the Danube River and the tributaries. So what we wanted to do was to evaluate, on the one hand, existing methodologies. We wanted, based on this evaluation and based on our trials, to show perhaps best practice options for future. We wanted to do, of course, a measurement in the different participating countries to find out how much microplastic is in the river. So to give a rough estimation on the microplastic pollution situation, to do also an assessment on the laboratory analysis, not only on the sampling, but also on the indoor analysis. And yes, at the end of the day, to give a sort of guideline or recommendations for the future sampling and analysis. And as we did this work together, we will also do the presentation together. And I want to ask my colleague, Gabor Bordós, to come on the stage and to continue, and he will introduce and show to you the different methodologies that we used during our investigations.
Thank you, Gudrun. Hello, everybody. We decided together yesterday to merge the two presentations together, not just to confuse you compared to the program, but really because we worked together during the samplings, and also we want to compare on some extent our results. Yeah, I'm sorry. Okay. I didn't get used to this kind of presenters. So the main goal of the samplings was that we've seen that there are different sampling methods, not only in the Danube Basin, but across the world. And we try to compare, on some extent, the most popular ones. One is the net device you can see here, which is the concept is originating from the oceans and seas, where microplastics has been initially identified with these kind of plankton nets since 30-40 years ago, but during 20-30 years nothing happened, and the microplastic research started after the 2000s, sorry. And this kind of method, yeah, I will get used to it. This kind of method is kind of an adaptation of this monitoring strategy that is applied on the open seas, but you can see that it is more diverse, more complex. It is not only applying a surface monitor troll, but also water column and the bottom troll with different mesh size nets. Different sampling methods has different advantages and disadvantages, but Gudrun will summarize this in the second half of the presentation. So now I would like to introduce how the methods are working. The second sampling method that has been developed by our team at Wesseling is a pressurized fractionated filtration, where we have different mesh sizes, and we pump through a few cubic meters of water through these meshes. And you can see the third sampling method. What we have applied is the sedimentation box that has been already introduced by the previous lecturers. this was the first concept that has been applied along the whole Danube stretch during the JDS4. And we tried to pick up the sampling locations according to the JDS4, and we settled several sampling locations, and the sampling concept at these locations was not to take only one sample, but across the section we designated 3 sampling locations, and as the net measures in different depths, we try to adopt the pump sampling to this. So at different locations we attached the suction valve of the pump directly next to the mantenet. So this means that the water was sampled exactly in the same time and exactly in the same place with the 2 different methods. And additionally, we have done a surface sampling with the pump crossing the whole section. Sedimentation box was also placed where it could be organized, but as this is a different sampling approach, this couldn't be exactly in the same time, because net and pump sampling is rather a snapshot. Sedimentation box is a 2-week-long composite sample, and also there we cannot measure the flow rate that is passing through the sedimentation box, so the results are not as good comparable with the sedimentation box as with the net and the pump method. So here you can see the designated sampling locations. As much as we could, we wanted to stick to the JDS4 sampling locations. Of course, we couldn't sample all the locations, but we wanted to designate sampling spots at the main participating countries on the Danube stretch. And you can see the different legends for the different sampling methods, and across the Danube at all spots all methods has been applied, and we have taken samples from the Tisza River with the pump method on the Hungarian stretch, and at the tributary of the Tisza River we applied the net and the pump method as well. Here you can see the sampling method for the pump, which is based on the fractionated filtration that I've been introduced. And here is the sedimentation box. So as I've said, here we cannot measure the flow rate, but we have stick to the protocol that has been applied during the JDS4, and we've implemented the sedimentation box for 14 days. So based on Ati's presentation, I got the impression that we should show some of, or at least one of the movie that is, can we get some voice, please? It's much better with the music, but the most important is the visual part. So this is the first joint sampling that has been organized in the beginning of the COVID, of the first COVID wave, and it was very interesting that we organized everything online, and finally in a nice April day we met with the colleagues from Austria and also colleagues from Serbia were participating to know how to organize the next samplings that have been planned to Serbia. And it was really interesting to see on the site how the different sampling methods can come together, and how we can just the practical part, how we can join the suction valve of the pump to the nets. And yeah, it was quite nice. The weather was not so nice, but we've successfully applied all the methods on the southern part of Budapest, and it was very good that the film Jungle team shooted this movie. So you can check it on YouTube. It's much better with the with the music and without my narration. So, but after sampling, we have to analyze the sample somehow. And at Wessling, we applied the density separation combined with oxidization. And finally, we filtered the sample on a small filter, which is 25 millimeter in diameter. So you have to imagine that several cubic meters of water has to be prepared to a 25 millimeter filter. But after this preparation, the whole filter area is measured by an FTIR microscope, which helps us to really identify which particle is plastic and which particle is not plastic. And we go through all the around 1 million points of the filter if we put 25 micrometer raster on the filter, because this is the measurement size. So 25 micrometer pixel by 25 micrometer pixel. All this filter is scanned with this FTIR microscope. So here you can see a resulting sample after sample preparation, and the resulting microplastic maps, which shows that above a certain correlation with the reference spectra, which particle is a plastic and which particle is not a plastic. I mean, which is not plastic, it's white here, which is some type of plastics, is marked with different colors. Just to highlight it a little bit more interesting, this is not coming directly from the Danube. This is a wastewater effluent sample going directly to the Danube. But you can see this is more colorful here, like the Danube sample, and you can see much bigger particles, which are red and green, so supposed to be plastics. And after the analysis, if we get this microplastic map of the analyzed filter and we overlay it, then you can see, especially at those particles which has a certain shape, that this is quite nicely correlating. Not perfectly, because the different images have been shot with different microscopes, but it is a good indication of overlapping. And of course, we do not evaluate the results based on the images, but the images are based on a certain database where all data are included, and with the use of this database, Gudrun will show how the evaluation works and how the results we can compare. Thank you.
Okay, yes, as Gabor already mentioned, we had somehow to bring all the material we sampled, in our case with the net, also on a very small filter. And if you have a look at the pictures from our samples from Hungary and Serbia, so the first thing, and this was really something we struggled for a very, very long time, was to isolate somehow the microplastic, because if you put all the mud on the filter, you will see nothing. And therefore, we really had a lot of, to put a lot of effort in dewatering. We used Fenton reaction to get rid of the organics. We did enzymatic treatment. We did density separation. We tried it in different directions, starting with density separating and ending with density separating, so to find a methodology that fits best to our really samples with a lot of mud in, with a lot of organics in. And this is one of the disadvantages, I think, of the net methodology. Yes, and then we realized during the project we had the chance to purchase a new, very high sophisticated microscope, a little bit similar to that what Gabor uses, but having costs about more than 200,000 euros, having a long time to wait to get this. And then we thought, okay, if we want to provide a methodology that can be used in all the countries by different partners, perhaps it should not be this very, very high sophisticated solution, this perhaps will not be possible for everybody to afford. And therefore we split our samples into two, one going with the high sophisticated solution, doing filtration and then measurement of the subsamples with this very expensive, high sophisticated device. And the other one where we went for really microplastic picking by hand under the microscope, so old school, let's call it like that, and then working with a not that expensive ATR, FTIR spectrometer to find out what it is about. Yes, then first of all we thought, is it really reliable to go for this hand picking? And therefore we put some extra particles in one of the samples to find out how much of these particles we will be able to recover them again. And we found that our recovery rates have been really high. So for polyethylene lids, for example, we really had 100% recovery of the pieces that we put in before, and also for the others. So the worst case was for one sample where we only had a recovery rate from 88%. So from that point of view, I say the hand picking should work. Then there is another issue that I want to point out if we want to compare the different sample methodologies. We have here a comparison between the net sampling and the pump sampling. With the pump, on each sampling area, we measured about, as a mean value, 3.8 cubic meter. So on three sides, so at the bottom and in the middle and on the surface. And with the net, it was more than 1,000 cubic meter. And therefore, it's also within the net, of course, we find more particles. But the interesting issue is not what you sample in total, but what you sample per cubic meter. But just to show and to think a little bit about reliability and also to make you aware of what do you have at the end of the day in your sample. So these are the results you can see from the pump, and you can already see we have here one spot where we have really a high number of particles identified, and these results are, and this is important that you remember that for the next slides. This is the whole results from the pump measurement, so including all microplastic particles smaller than 1,000 micrometer. And all the next slides, we will only focus on that part that we can compare. So this will be microplastic between 500 and 1,000 micrometer, because we, with the net methodology, we have not been able to go into the, I don't know, 50 micrometer measurement section. So, and therefore here we have about, in the highest case, about almost 300 particles per cubic meter. Most of the samples were below 50 particles per cubic meter. And what we also can see here, of course, is, I hope it's, that most of the particles belong to polyethylene. What is also important, if you want in future decide to go for one of the solutions, is how is the particle size distribution. And what you can see here, the smaller the particles, the more you will find. So if we, with our net methodology, only focus on particles being bigger than 250, or what we will present today, being bigger than 500 micrometer, we lose a lot of particles, of course. Yeah. For the sedimentation box, and this is also perhaps, if you remember the slide I showed before, we had really, or I will make you aware again, the first 4 bars are for Austria, where we have not that much microplastic particles, and for the sedimentation box, we have really a very high amount of particles detected in the box. What is wrong? No, nothing is wrong. The first picture showed microplastic particles in 1 cubic meter, and this is what was all the microplastic particles, because you cannot focus on the cubic meter with the sedimentation box. So I think you already realize you cannot use the sedimentation box for all the questions you have. Perhaps it's a very good methodology to compare 1 year with another year on a certain location, but to compare Austria with Hungary, I'm not sure. Yes, these are the results from the nets for the size 500 to 1,000 cubic meter. And here we have one special effect for Hungary, and you will see here, oh wow, what is this very high bar for Hungary? And this is chewing gum. So we had one piece of chewing gum inside, and this spread up in a lot of smaller pieces, and therefore we have this very, very high amount here in Hungary, which is not typical for the Hungarian sample. But also here you have to be aware, if this happens by chance, and you don't know that it is chewing gum, you will not find out even that it is chewing gum. So this was only because we have been picking by hand and have seen it before, and therefore could measure it in the correct way. So saying, please don't go for one sample, go for more samples to find out such issue with things that might not be wrong. Yeah, we have here also, we try to compare the results with and without the chewing gum to just show that this affects the total result, also concerning what is the composition. And what we, I think, can see very clearly here, and I think this is also the same with the pump results, if we go for the Tisza River, and the sample was taken where the Tisza went into the Danube River, we have really by far the highest amount of microparticles in the Tisza River. Yeah, comparison between for the results of 500 to 1 micrometer for the high sophisticated methodology with the net sampling, for the particle picking with the net sampling, and for the pump sampling. So what we can conclude is that we have more or less between 1 and 7 particles of this size, between 100 and 1,000 micrometer in our samples. And everything else is really very difficult, because as you see, we talk about per 1 cubic meter, 1 to 7 particles. So there, of course, you can have, yeah, if you detect one more, it really has a very, very big effect on your overall results. We have more or less similar pictures dealing with the composition, so being between 40 and 60% with the polyethylene, followed by polypropylene. We have this specific chewing gum issue with the net sampling. Yeah, to come somehow to a sort of conclusion, if we should propose to you a sort of guideline, what should be used in future? Of course, this is not very easy, and this depends on, of course, the specific question you want to solve. What we can say is the practicability of the net sampling, it's definitely more complicated than for the pump methodology and for the sedimentation box. So you need more stuff to solve this and so on. The duration of the preparation and the duration of the measurement is same time for the pump and for the net. For the sedimentation box, you have to go there twice, bring it in, let it in the water for 2 weeks, take it out. The costs also, because you need more manpower, are higher with the net sampling and are, I think, cheapest with the sedimentation box. For the necessary skills, also here, I would say you cannot send out a student with the net sampling, and also not really with the pump, but it's not that high sophisticated with the pump and the net as it is with the pump and the sedimentation box. What you also need for the net sampling, if you take the samples from a bridge, you need a lot of approvals. If you want, so you have to stand on the bridge most of the time. You have there to avoid the traffic and so on. So this is a specific issue you have to solve. But the big advantage from the net sampling is that you can go for a representative sampling over the water column. This was also possible for the pump method as long as we put the pump to the net. So I think it would be difficult or a specific effort to go for the water column with the net alone, with the pump alone, without having the net beside. Of course, this is not possible for the sedimentation box. And the representative sampling over the river cross-section is possible for both the pump and the net without problems, and of course not possible for the box. For the analysis, for the net sampling, it will not be possible, at least our opinion, to go for a fraction smaller than 250 micrometer, because this will be too heavy for the net. You cannot let the net for a long time into the water because it will get closed because of the organics and the mud. With the pump method, you will lose the bigger particles because if you will let them in, this might also cause problems for the pump. For the sedimentation box, you can take everything smaller, 1 centimeter. You have a very heterogenic sample composition. For the net sampling, homogenic size in the pump method, and also homogenic size distribution in the sedimentation box. In the sedimentation box, it's mainly inorganic impurities. In the net sampling, it's mainly organic impurities, what is much more difficult to get rid of them. Therefore, we really need a very long time for sample preparation for the net sampling and also longer time for the sedimentation box, and we have comparably clean samples with the pump. The measurement itself lasts as long for all the samples, and in our estimation, because you need that much manpower, net sampling seems to be the most expensive solution, but you have the most sampled water volume, which you could interpret that you have the more, you have a bigger sample at the end of the day. A bigger sample might be more reliable results. Yes, to come to a conclusion, sorry. The optimal sampling method definitely depends on your boundary conditions. So if you are not able to buy the very expensive microscope, perhaps you will go for the hand picking. If you go for the hand picking, it will not be the pump because you have that small parts that you perhaps will not find and so on. The pre-treatment steps may influence the results. So you might have undetected particles. The sample preparation efforts, of course, depend on the sampling method. And what we realized with our chewing gum, that the porous plastics can be crushed by treatment, and then you have a lot of particles. So not only particle size is important, but also mass of particles is relevant for the future. Only plastics that are present in databases are detected. Here you can also, if you have a bad database, you will not detect everything and all plastic particles as plastic because the database will not tell you. So go always for the expensive database. Picking by hand and individual identification, having lower investment costs might be a cheaper option and looks fine to work. Focusing on smaller fractions, definitely the pump device should be your choice. For the future, there is still a lot of research demand open. The research demand, so The pre-treatment and analysis method needs to be further investigated, so it's still not, we still have not come to an end on that. I think this is also international the same. So the recovery rates for already weathered materials needs to be further investigated. The removal of bycatches needs to be improved, especially for the net samples. So we all together have to go much more for quality assurance, quality control. So look for recovery rates, look for secondary pollution, what is coming from outside. There is, at least we had the problems with fibers because they are really very difficult to be detected and analyzed. What is about the tires? Why everybody says there is a lot of tires and we have not detected that much, I think. So how can we find them? Let's dig for tires in the water. Yes, also the determination of the error rate with FTIR microscope should be improved for the future. Yes, thank you very much for your attention, and I can conclude that it was a really very, very interesting project for us all to have the chance to compare results with different methodologies, and I hope for the future we can contribute to more knowledge on that. Thank you.